everybody. I'm Ted Young, one of the co-founders of OpenTelemetry, here with Josh MacDonald, who's leading the metrics effort over in OpenTelemetry at the moment. And I thought it would be fun to just have a quick conversation about traces and metrics and how they can potentially work together in OpenTelemetry. Because we've got this kind of like interesting value proposition, which is we're combining all of these data into a single stream and giving all of these data sources access to the same context. So we've been thinking on a certain level about tying the data together at the data model level, but Josh has been one of the people actually doing some of that work on the metrics side. So Josh, maybe to start it off, like at the data level, how do you see traces and metrics correlating with each other?
Hi, everybody. Let's talk about that, Ted. Yeah, so it's an interesting idea to think about what we might mean when we think about linking together traces and metrics. You can kind of see that problem from both angles. I want to put some traces into my metrics, or I want to put some metrics into my traces. And I don't think it's harmful to think about that in either way. There are precedents in both cases. So we can kind of start with looking at the way people have traditionally done this. You can think about going all the way back to Dapper, the system that Google did, and I was part of over 10 years ago, where I think they first introduced the idea, or at least the modern idea, of an exemplar. This came together through the histogram, or the distribution metric type, where you're going to observe some latencies, we'll say. And in addition to that, you might attach a trace ID or span ID to help you identify for some latency bucket in your histogram, how do you find a trace that's associated with that particular latency? So this is being done for span latencies early on in the Dapper system. And then I think the open census system that was part of the OpenTelemetry charter and was work that Google had done after Dapper, just sort of generalized that notion and said you could put span ID and trace ID, one per bucket, into your metrics data in order to link together spans in a downstream system. So that's sort of the starting point. And we can do that more or less today. And the Prometheus system is also doing that today via the OpenMetrics protocol.
Cool. So OpenMetrics also has a place in its protocol for exemplars.
Right. And generally speaking, this can be either generalized to arbitrary extra label dimensions, or you can just think of it specifically about span ID and trace ID. And so there's some ideas in the sort of traditional sense, all you want to do is toss in a span ID and a trace ID. But in the general sense, you might have other identifiers or other quantities even that might be correlated with some metrics observation that you want to include as example data to help further explain some metrics data. So that's kind of, again, looking at metrics data. We're looking at ways of putting span information into your metrics data. So how you might use this is if you're, as long as you're not sampling, well, actually, sampling is an independent question. Sometimes we say we're going to only record sampled spans in that metric stream, and then you're able to collect sampled traces that are associated with each latency bucket in your histogram. We can also talk about how you might look at monitoring the metrics for an entire span of activity. And that's something that I think is less common today, and something that we might be able to do with the OpenTelemetry metrics and the OpenTelemetry span data model. If you were just to imagine that for every metrics event, you attach an additional 2 labels, one's your trace ID and one's your span ID, to every event, then in theory, you could aggregate every single metric by span and every single metric by trace, if that was something that you thought might be interesting to do. And most metric systems today are really not built for that type of data delivery. You wouldn't expect to deliver one time series per span per every other dimension that you're tracking your metrics. And so for this reason, when you start to think about metrics and spans together, you might imagine having a stream of metrics data per span, actually. And then you could consider ways of having sampled metrics emit from your SDK in the form of a span. So you might be sampling spans and gathering metrics in those inside of those spans. And that takes a little bit more of explaining to figure that out, but it's something that the OpenTelemetry metrics data model is prepared for, because we talk about how to add labels, and this is just another label.
Yeah, so maybe we can like, this turns into a brain teaser really quick. So I think maybe some basic examples are probably in order. So correct me if I'm wrong, but the most basic version of this might be you're emitting metrics. Let's say you're emitting HTTP status codes, right? Every time there's an HTTP request, you want to count a metric by status code, right? So this is a request, it had the status code. And if that request was also being traced, there would be a span ID and a trace ID available at that time. So you would be able to attach, let's say you're looking at 500s going up, and you want to say, what are these 500s? You would then be able to, from your metrics graph, be able to get examples of transactions where that 500 occurred within that transaction. Is that kind of like the basic?
Yeah, that's an example of what we call an exemplar, and the example that you pictured was one of a counter. Traditionally, this has been done only with histograms, where you want to check some value inside of a dimension or inside of a distribution. But the case that you mentioned is an example where an exemplar for a counter makes sense. And the OTLP protocol does include support for counter exemplars for this reason, so that you could include a span correlated with a rise in error rate, for example, or a rise in 500 rates.
Yeah. There's also some degree of, one thing I find a little difficult here is often the easy to go to examples are things like error rates and status codes. And these are all information that you would already have as attributes on a span, which makes me feel like there's also the ability to potentially just go the other way, which is to start just creating metrics out of your spans, right? Like if you have spans and you have status codes on them, like, can't you just do all of your counting there? Or does sampling and other things kind of start to get in the way of that?
Actually, I think that those two fit together very well. And this is one of the things that is maybe not immediately clear to the people who come into the project, where metrics has never done sampling very well, or it's never been part of the standard canon for metrics in the open source world. There's a way in which you can view each span as a count of one, and in some systems it's actually called a multivariate metric system, where you say, I'm going to count one and I've got 10 labels, and really I can think of that as 10 dimensional counts of one, labeled by optionally any other of those other 9 variables. And you can project that single count with 10 attributes into any number of dimensions and metrics. It's essentially, and it's not just a thought experiment. This is actually how many systems work. And this actually works when you sample. It's one of the reasons why people choose to do it. So if you say, I'm going to sample my spans 1 in 10, and I also include my notion that any one span can count for one error or one request, for example, then I can also just say that now I'm going to count those as 10 requests or 10 errors, so that using sampled multivariate metrics in the form of a span is actually a reason why people have that type of data. So raw statsd is one that includes samples, and the Amazon EMF format, embedded metrics format, is one that's a multivariate metric format, essentially like a span, where each event counts for some number of events, and it's many different dimensions that you can interpret out of that.
How does that deal with outliers?
Well, if you're sampling, I take it.
Yeah.
Sampling doesn't necessarily help you with outliers in the common case. I mean, the whole idea of sampling is that you can approximate something by collecting much less, and therefore you're not going to necessarily find outliers. And that's one reason why many users would choose not to add sampling.
Right. Or doing sampling after the fact, right? Tail-based sampling, I think, is what we're starting to, feel like that's become the default name for that form of sampling at this point.
Right. But I think in general, the idea that we want to record sort of high dimensional data that we can then project into low dimensional data, we can actually do that outside the process. So you can say, I'm going to record some spans and they're going to be unsampled. And inside my collector, I could turn that into 3 metrics. One is the error rate, one is the throughput, and one is the latency distribution. Those are all sort of standard metrics that you might get from a span. And instead of doing that inside the SDK, you may as well just do that from your stream of spans. In that sense, you are creating multivariate metrics out of spans and turning them into single time series somewhere else.
Have you thought about, like, I mean, there's kind of like the default use cases, right? Like you have latency and you want to see examples of transactions that represent that latency. You have errors and you're like, well, I want to see the actual errors behind this count. Are there like other examples you can think of where combining, having exemplars available on your metrics would be helpful?
Right. You might think of a case where you're looking for more than one coincident variable at the same time, which you don't get from a bunch of independent time series. So I'm looking for an example of an event that had a high request bytes and a timeout, because that might be explained by the size. So if I only have a request size metric and a latency metric, I'm not necessarily able to see the individual correlations between high latency and request size or error rate. Right. So these are ways of finding individual examples to explain behaviors that we can't do with just metrics.
So this is basically because when you have spans, those operations have a large number of attributes on them potentially. And so you're able to coordinate across these different, if you have multiple metrics associated with the span, and that span has a number of additional attributes that weren't labels on either of those metrics, you would start to be able to find relationships that you wouldn't be able to find otherwise. Is that the basic idea there?
That's right. And we can use these individual data points to sort of establish correlations in the broader sense. It's not just individual counts that we might interpret from a span, though. It's also like, say request size. So I can say that this span, which has a request size attribute of 300 bytes, counts for 300 in the counter of bytes, for example. And so I can look for, and that's another case where the span serves as an exemplar for some variable that you can then correlate with latency. Most of our examples that we've discussed here are counters. It's also the case that you can use gauges here. And there's a really common or desirable way that you could use metrics to inform spans with gauge variables. And it's the things like the runtime state or your host information, like the current memory size, the current garbage collection statistics, the current CPU usage. All of those, if you put them directly into a span, means that you can use your spans like as a source of truth to examine your system behavior without having to go off to a metric system to bring in correlated information, which makes your investigation much easier, because you can just see for this span, it happened during a moment where the CPU usage had spiked, or it happened during a moment where memory usage was very near to it, or something like that.
Right.
Those are things you can't get from spans or metrics alone.
Is this something you could do in the collector? I mean, I can see so just so people are clear who are listening, the value here is resource contention, right? You have a number of operations happening concurrently on a machine at a given point in time, and you've got CPU and memory usage at that point in time, and you might be able to start tracking down and attributing some of that resource contention and issues associated with it to seeing patterns in the operations that are happening around the same time you're seeing CPU spikes and stuff like that, right? So like that's the basic value proposition there.
Yeah, and I think the idea we would say in OTel of having a resource identifier is that you can correlate your metrics in your spans,
right.
And that means that whether you do so in the process where it's very simple to correlate to combine those streams, or you do it outside the process where it's actually a lot harder, but potentially, you've deferred the cost. You can say someone downstream might want to join these metrics and these spans together, and they may do so using my resource identifiers. And that means you can configure a collector plugin that might choose a few gauges of high importance and attach them to every span coming through. And that means that, at startup, you might be missing that information. So you're going to have like some absent data, and then as soon as that information arrives, every span forward is going to have those sort of last value of a gauge set. Can be very useful.
I mean, I can certainly see it's fairly common for people to be, how do I put it? It's a little notorious trying to capture machine metrics from within your application process, right? Like that's depending on the language, like there's often some barriers or difficulties with doing that. And it's more common for people to run like an agent or a sidecar, like another process on the machine. And all that thing's doing is recording gauges about machine properties like CPU and memory. And then either that sidecar agent itself is the collector, or which I think would be the common case if you were doing it that way, or you're running a collector somewhere else, but it's receiving all of this data with the same resources attached to it at roughly the same amount of time, depending on your sampling rate with things like CPU and metrics. So it seems reasonable that within that collector, you could actually combine these two data streams. Like you're just saying you have a current CPU and memory
it's more than just reasonable. It's actually well defined. We're trying to make sure that when you set a gauge, the meaning of that action is to say that until the next time I set this gauge, it's to be used as the last value. Therefore, right. and all of our OTLP spans and all of our OTLP metrics values have time series or time ranges essentially that they're associated with. So you can look that up, and that's what the data model is trying to answer.
Right.
So that you can do that in your data store ultimately. And there's definitely a performance trade-off that is possible when we make this decision. So right. If you want to join your metrics inside of the SDK, if it's possible for you, that is the most trivial case. If you want to do it inside an agent, that is the second most trivial case, because your machine metrics apply to any data that passes through. You don't have to actually do any matching between resource values. You kind of know that anything passing through me gets these values. And then there's the sort of general case where you might have a streaming processor like a collector taking this data, and it becomes a little bit harder to do that. And then there's a case where you put that into your data store all the way down, and you do this on your read path. And it turns out that systems that require more scale are going to want to do that on the read path. You're going to just write all that data into your data store. So you'll know the current value of a CPU, and you'll know the current value when it was written, and you'll know the span has a timestamp, and you can look that up as you need on the read path. You've deferred all the costs to your fancy system. Right. For the open source community, we just need a much simpler model where you can stream it through and write that data out. And this is one of the reasons why we need to, this is one of the things that we have to do for OpenTelemetry to support push in a world that's traditionally been pull, because it was so much easier to apply these gauges and sort of resource discovery information when you pull data, because you know what you're pulling, rather than when you push data, when you kind of don't know what you're pushing in a sense.
And so if you're pushing all of this data, then you're putting it back together later downstream is what you're saying.
That's the idea.
And that's so potentially cheaper.
We're a bit off on a tangent here, but the idea that the way Prometheus does service discovery is it pulls from an API server, and then it knows all the information. It uses that to pull from some targets, but it means that every Prometheus server had to pull from the API server. You could instead pull from the API server once and write that information into your store. And then you just push all the other data into your store. And it means that you can have this higher scale and do that stuff on the read path. And that's just a different architecture than the open source community has. And so we're talking about being able to do this on the right path inside of a collector, because that's the sort of more resilient, more easier way for a community to receive the data, is to have it already done for you. Right. If you can't do it inside the SDK, and you can't do it inside an agent, then you might have to do it inside a collector. It's pretty hard to do, but it's not impossible.
Right. So it's basically, there's a lot of options here, depending on what kind of processes people are running, what their topology is as far as their telemetry pipeline is concerned. And then last but not least, it depends on what kind of data store they're putting the information into. If they're putting it into a data store that can combine it again later, then they could defer the cost completely on the right path. But for a lot of systems, they might be in the middle ground of wanting to put this data together, like in the collector, and we're going to provide that as an option.
That's right. So I'm looking forward to a collector plugin that can receive spans and apply the current value of gauges, for example, so that you have just additional span. Well, this is a case where we might want to extend the data model. So the span doesn't really have a way to store a metric stream except in the form of attributes. And so you can have counter value equals cumulative, you can have gauge value equals value, and that might be the right convention, but it might not be.
Yeah.
Imagine a way to store a histogram event. It doesn't really qualify because it's a multi-map at that point.
Yeah. And you got to wonder, well, I guess when you're talking about deferring, then you're talking about the case where you want to know that like on this resource, on this machine, at this time period, I saw a spike in CPU, and I want to find all of the operations that were associated with that machine at that time period. The operations themselves don't necessarily need to have that CPU recorded on them, provided the system you're putting it all into has access to all of this data. Whereas if you're actually shoving this data into like disparate systems at the end of the day, which I think a lot of people are going to be in this mode where they're at the end of the day, the metrics go into a metric system, the traces go into a tracing system over there. Those are situations where you'd want to be writing all of that CPU and memory data onto your span so that in your tracing system, you can look it up. And then potentially adding exemplars to go into your metric system, presuming that metric system at some point has the ability to, like, at minimum, have a way to like link over to your tracing system. You could like grab that trace ID.
You've described that for the current systems that are out there in the OSS world, you really need to have a way to put span data into a metric system and metrics data into a span system, because those systems are not ready to rapidly adapt to the world where you have both in an integrated place and where you have a data store that can join that data on the read path. But what's the requirement for OpenTelemetry is that we have this resource identifier that is sort of makes it well defined for how you find the data that's correlated at a given point in time.
Yeah. Awesome. Well, I think that's all we have time for today, but this is like exciting new ground. I'm excited about this because I feel like this is the area where OpenTelemetry is starting to actually push the boundaries of what systems can currently do. So hopefully we'll have a follow-up soon with real life examples of this kind of metrics and trace correlation happening in reality.
Great, thanks, Ted. Yeah, I've got some examples. I'd love to talk about them next time.
Great. All right. Talk to you later, Josh.